Another Leetcode Daily. Today we have course schedule 4. It's a series of a course schedule problem where it says there's a total of num courses you have to take, labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites A and B means you have to take course A if you want to take course B. So basically A is a prerequisite of B. For example, 01 indicates you have to take course 0 before you can take course 1. And then they said it can also be indirect. So basically A is a prerequisite of B, but B is a prerequisite of C, and so on. So it's a chain of prerequisites, basically. It says you're also given array queries where queries of I is equal like this. For the query, you should answer whether this is a prerequisite of this. This is a prerequisite of this, basically. And then return the answer. So it's just a simulation, not simulate, some sort of a simulation, but... So basically, one thing we could do, there's different ways of solving this. Obviously, there's a bad way and there's a good, better way. I don't know if there's the best way. I don't know what that's about. But we could, for every query, we could just do a DFS starting from here, seeing if I can. Starting from either one. Honestly, going the opposite way, and then seeing if you can reach it or not. That's the way. But that's really inefficient because as you go through the queries, you're gonna see indexes getting repeated a lot, and then you're gonna have to do the same work again and again and again, which can be very inefficient. So basically, a way to do this is to actually process the whole courses, right? Have them cached, and then just use the cache to solve the queries, basically, which is what I did. So first thing I did was create an adjacency list. Creating an adjacency list means like for every for every course I just have its prerequisites in an array, basically, because doing so it becomes easier to do a DFS when it's like a hash map based. So and then I'm gonna, like, as I do a DFS, every time I complete one, I cache the result, right? Something very, very important if you've solved course schedule problems before. The thing is, I asked myself, are there cycles in this question? But looking at the constraints, it says the prerequisites graph has no cycles, which saves a lot of effort in actually tracking cycles, like seeing if I visited this course before or not. So now, we do a simple DFS, basically. So what this DFS is about is basically, first of all, if there is not an entry in the adjacency list for this course, that means this course has no prerequisites, right? So I just return a set. I use sets for easier lookup time because it's of one. We'll see that in a minute. So basically, if there's not an adjacency list, if there's if the course is not in the adjacency list, just return the set with that course, because probably it's going to be getting called from an upper course, so I need that entity there, basically. So anyways, if it's in the cache, just return it. Don't compute it again. If this course is in the cache, I already know its prerequisites, so don't compute it again. And then I'm going to initialize this set. This set should govern all the prerequisites of this current course. And then I'm going to iterate over adjacency lists, the prerequisites. First of all, I'm going to add it because it is a prerequisite anyways. And then I'm going to DFS to see its children, basically. So I'm going to DFS to get the set of its children, and I'm going to union that with the current set. So that's what I do, basically. I add the child, I look at its children, and I union that again. And then after I finish the iteration, we should have a big set of all the prerequisites, right? In any order, doesn't matter. And then I attach that to the cache, I return it. Then I iterate over all the courses, and I just do a DFS to actually get the cache, load the cache. And then I iterate over the queries, and then I just check if it's in cache, and if the prerequisite is in that course's requirements, basically just return true. This is just gonna like return either true or false, and then I just replace queries of I instead of having to do a new array, and then I return queries. So yeah, the time complexity of this is O of n, because we visit each node most once. We don't have to visit a node again because we cache the results. So yeah, that's been it for this one, guys. See you in the next one. Thank you.